Okay, so let's unpack this. We've been doing a deep dive into the specs of the DBXDI1 Active Direct Box.
Right.
And our mission today is really to figure out why this little box is so often the one thing that stands between a great live sound and a total signal chain disaster.
It's the essential tool for, well, for taming the chaos. If you're connecting a high impedance source, think an electric guitar, a big keyboard rig, a bass amp.
Anything with a 14-inch jack. Man.
Exactly. You need to connect that directly to a mixer, and this box is the translator. The whole promise of the DBXDI1 is delivering a signal that's balanced and just incredibly clean.
That's what I want to focus on. Forget the theory for a second. Why does my guitar sound so thin and awful when I plug it straight into a mixer's line input, and why does this little thing fix it?
It all comes down to signal integrity, and that means level and impedance matching. That's the key.
Impedance.
Your guitar has a really high impedance. We're talking over 250,000 ohms, which is just terrible for sending a signal down a long cable. The DBXDI1 takes that signal and completely transforms it, dropping the output impedance to around 600 ohms.
Wow, that's a huge drop.
It's a massive shift. It takes that weak, fragile instrument signal and turns it into this robust, low-impedance signal that can, travel 100 feet down a snake and not lose all its high end or get muddy.
And that transformation saves so much troubleshooting time. For any musician on the road, that kind of flexibility is everything. Tell me about the inputs and outputs, especially that signal split feature.
Yeah, the input stage is built for anything. You've got 2 parallel quarter-inch jacks and even a parallel XLR. But the crucial part for playing live is the signal pass-through.
The through jack.
The through jack. It lets you send that clean balanced signal out the main XLR to the soundboard, while at the same time sending the original untouched signal right back out to your amplifier on stage. No extra splitters needed.
That right there makes it a workhorse. Now, this is an active unit. It needs power. Why do I need an active DI when a simple passive one doesn't need a battery or phantom power?
Good question. You need active circuitry for 2 big reasons: consistency and headroom. An active DI gives you a strong, consistent signal no matter what you plug into it. And the power options are really solid.
It has LEDs for that, right?
It does. It can run on phantom power from the mixer, pretty much anything from plus 18 to plus 48 volts, or just a standard 9-volt battery. That's non-negotiable for serious use.
Okay, that covers reliability. But what about noise? The ground lift switch is almost legendary for saving gigs.
Oh, absolutely. The attenuation control is useful, but that ground lift switch, that's your get-out-of-jail-free card for hum.
So when the stage power is sketchy.
Exactly. Your amp is on one circuit, the PA is on another, and suddenly you've got that awful 60-cycle hum. You flip that switch, it breaks the ground loop, and poof, silence.
I saw in the specs that the attenuation lets this box handle up to a plus 52 dB input. That seems insane. What is putting out a signal that hot?
Well, that massive headroom is the beauty of an active design. It means you can plug in a quiet vintage bass with the pad at 0 dB and it sounds perfect. But then you could take a super hot modern synthesizer, slam the pad down to minus 40 dB, and it handles that blistering plus 52 dB signal without even breaking a sweat.
It just won't clip.
It won't distort, it just delivers a perfect controlled signal to the board.
That capability really speaks to its quality. Let's get into the numbers that prove this clarity. What are we looking at in the specs?
The proof is in how little noise it adds. I mean, the distortion is just ridiculously low. Total harmonic distortion, or THD, is less than 0.005% at 1 kilohertz.
Which, in practical terms, is nothing.
It's less distortion than the air in the room. You couple that with an output noise floor of less than -100 dB, and you're getting a signal that is fundamentally dead quiet.
That's pristine. And the frequency response is 10 Hz to 70 kilohertz. It's capturing everything, from the lowest bass rumble to harmonics way outside what we can even hear.
Which ensures the stuff you can hear is perfectly in phase. And all of that clean, sensitive circuitry is wrapped up in a tough-as-nails metal chassis you can throw in a gig bag.
So it's acoustically transparent and physically rugged. It just takes whatever you give it and makes sure the front-of-house engineer gets a clean, professional feed.
That's the job, and it does it very, very well.
It absolutely does. So here's a final thought for you to chew on. Given these specs for killing noise and managing impedance, think about this. How much clarity are you actually losing every time you skip this step? What subtle detail, what potential gig-saving noise floor are you sacrificing by not putting a quality active DI in your signal path?